How will the history of our universe end? And most importantly, when will it be? Is all this not eternal? The universe is almost 14 billion years old, and it would seem that it can safely continue to exist forever. But actually, no. Everything comes to an end. Everything. Even stars and galaxies. Everything tends towards a state of minimal energy. And because of this, 3 possible apocalypses are waiting for us. To understand what will happen to us, we must first know what decides the fate of the universe. Meet dark energy. In 1998, scientists observed a new supernova, a Type 1a supernova, what's known as a standard candle in cosmology, used to measure great distances. The brightness of the explosion of such stars is almost always the same. So, measuring the brightness of the explosion as seen from Earth, one can determine the distance to the place where it occurred. There's another way to determine huge distances, using something called the redshift method. The details are a little hard to explain, but briefly, as the light from a distant object flies towards the Earth, it gradually shifts to the red part of the spectrum. So, measuring the redness of light from distant galaxies, one can determine how far they are from us. According to the first method, the new supernova was 7 billion light-years away, and according to the second method, 12 billion light-years away. The only way to explain where the additional 5 billion years came from was to assume that our universe is expanding, and that expansion is constantly accelerating. This is a big deal. It is precisely dark energy that is theorized to be responsible for the expansion of the universe. In a way, it's almost like anti-gravity, inconsequential here on our Earth and even within our galaxy, but exceeding the power of gravity at the mega distances between clusters of galaxies. This means that unless a faster-than-light mode of travel is invented, we will never be able to visit most of the universe. We'll be limited to our local group of galaxies, which includes the Milky Way, the Andromeda Galaxy, and several tens of dwarf galaxies such as the Magellanic Clouds. Even if you sat down right now in a ship that could travel at close to the speed of light, you could never leave the local group. All the other galaxies and clusters will fly away from you faster than you can approach them. It's believed that dark energy is evenly distributed throughout all of the universe and most likely always had, has, and always will have a constant density. The density of dark energy can have 3 values: less than -1, greater than -1, and equal to -1. The first theory, the Big Rip. Let's analyze the first case. If the density of dark energy is less than -1, then the universe will end in something called the Big Rip. According to modern observations, the lowest possible value of the density of dark energy is -1.08. Everything in our universe will end, in this case, in a minimum of 80 billion years. All observable objects, except for our galaxies, the local group, will fly away from us, all the while accelerating, until the speed of this expansion itself reaches the speed of light, after which we won't be able to see anything beyond our cluster. The first most distant groups of galaxies will begin to disappear in about 10 billion years. The nearest will cease to be visible after about 60 billion years. 200 million years before the rip, our local group will begin to disintegrate. As a side note, at that time there will be a new, larger combo galaxy here, the result of the collision and merger of our Milky Way and Andromeda, and about a dozen other small galaxies that manage not to get merged, but are in orbit around it. 60 million years before the Big Rip, this new galaxy, which scientists propose calling Melomedes, will begin to lose stars from its periphery and will completely disintegrate in another 40 million years. Solar systems will begin to disintegrate a few months before the end. The remnants of our solar system will stop spinning around the corpse of the sun, now a white dwarf, and will fly into the rapidly expanding universe about 3 months before the end. The planets will be broken about an hour before the end, and the basis of our world, the very atoms it consists of, will be destroyed in a nanosecond just before the final tear. Only non-composite particle points, elementary particles such as electrons, quarks, and gluons, will remain from the wild and unimaginable diversity of what was once the universe. They will never collide again and will form nothing new. Each elementary particle will move away from every other one faster than the speed of light. Nothing more will happen. Never. Ever. The second theory, the Big Crunch. If the density of dark energy is more than -1, then tens of billions of years from now, the force of gravity will win, and the history of the universe will end with a little more fun. By the way, this theory is the least likely, but we still don't fully understand how dark energy works, so the Big Crunch still remains possible. Due to the fact that the properties of dark energy are not fully known, it's impossible to name even approximately how much time we have left in this scenario for the end of the universe. You can only describe the events that come before the end, without being exactly tied to time. First of all, it should be noted that not only all of the galaxies, superclusters, and all that other fun stuff will converge, but that the size of the universe itself will shrink. When it decreases 5 times from its current state to a diameter of 20 billion light years, all the aggregate star stuff will merge into one supercluster, with the galaxies being the constituent elements of the cluster. They will remain. They will still spin around each other and collide, but they will not be separated by overwhelming distances. Unlike the previous version of the development of the universe, in this one, you can reach any place, anywhere you want to go, if moving at near light speed. When the universe shrinks to 1 billion light years across, the superclusters merge into one giant galaxy, and the cosmic microwave background temperature will reach 32 degrees Fahrenheit. That's 0 degrees Celsius, and all the stony planets in the universe will be suitable for life if there's water on them. So, let the universe shrink rapidly, and the CMB temperature will create a comfortable warmth, and life can be born. But, alas, the background temperature will continue to warm up for millions and even billions of years. The temperature will grow higher. Space will become smaller and smaller, until finally, even atoms will split and disintegrate. Everything will return to a state like that before the Big Bang. In the end, the universe will finally consist of one micro-singular mass of infinite temperature and density. What happens next cannot be predicted. Modern physical laws don't apply in such a place, but it is possible that the Big Bang will happen again, creating a new universe. The third theory, heat death. If the density of dark energy is precisely 1, the universe will slowly but infinitely expand at a constant rate. Clusters of galaxies will forever fly apart, but objects within the clusters will forever remain gravitationally bound. After a few tens of billions of years, the galaxies will exhaust their supplies of dust and gas from which stars form. The main sources of light will be long-lived red dwarfs, small, dull stars, often only 1/10 as light as our sun. After about 10 trillion years, the last red dwarfs will cease to glow and turn into black dwarfs. The universe will plunge into darkness, only here and there illuminated by the remnants of its former greatness, even dimmer neutron stars and white dwarfs. Gradually, all matter will be absorbed by black holes, which will grow to unimaginable sizes for trillions of years. Hundreds of trillions and trillions of years will pass until the black holes evaporate due to Hawking radiation. This happens because photons, with a very low probability, can escape beyond the event horizon of a black hole. Over a long enough period of time, black holes evaporate, leaving only photons and quarks and electrons in the universe. Occasionally, the electrons and positrons will combine into positronium atoms and then immediately annihilate. Thermal death has come. If this all sounds a little frightening, don't worry. At present, we have an entire universe full of bright stars and, I hope, worlds fit for life. No matter what happens, billions or trillions of years from now, we should rejoice that we are lucky to live now, at this perfect time when we can learn how our universe was born and how it will end. We can observe the universe in all its grandiose beauty right here, right now, and it is wonderful. If you have any ideas for future episodes, please leave them in the comments below. The author of the best idea will have their name presented in the video. What will be if we wrap you round and round with Scotch tape? Throw the whole package into a microwave oven. Roast it quite well. Feed that to a giant hungry whale. After that, drown you in the ocean. Then bury you alive, send you into space. Then let you drop back down to Earth straight to the bottom of the Mariana Trench. After that, take you out and dry you under a nice warm lightning storm. Dress you up, comb you out, stick you on a plane, climb to a height of 30,000 feet, and toss you out once more, where you plummet back down to the unyielding surface. Of course, without a parachute. What will happen then? Let's ask Arnold. How are you feeling, buddy? You still on your feet? Well then, how about this? There's no time to explain. Just click on the link in the description and watch the first episode in this awesomely great new cartoon series, soon to explode across the entire damn internet. Come on, press the button. You can't resist subscribing to this channel.
The planet J1407b is located 400 light-years away from Earth and boasts planetary rings that are 200 times bigger than the rings of Saturn. Scientists don't completely understand how this strange planet managed to acquire rings of such an enormous size. The rings of J1407b are so large that if Saturn's rings were as large, they would dominate the Earth's sky and appear much larger than a full moon. Inside the Crux constellation, approximately 300 light-years from the Earth, lies the loneliest planet in the known universe. Cataloged as HD 106906b, this planet is 11 times bigger than Jupiter. Astronomers have dubbed this planet as a super Jupiter. HD 106906 orbits its parent star at a distance 20 times greater than the space between the Sun and Neptune, which is about 60 billion miles. Its extremely unusual distance from its star makes it one of the loneliest and isolated planets in existence. Over 750 light-years away from our solar system lies a planet known as Trace 2b. This planet is remarkable because it is the darkest planet known to exist. This dimly lit and menacing planet reflects less than 1% of the light that hits its atmosphere. This is so little light that the atmosphere of Trace 2b reflects less light than coal and black acrylic paint does. The tiny fraction of light that isn't reflected by the planet's thick and suffocating atmosphere is faintly red, causing the planet to dimly glow in an evil red color. The planet 55 Cancri E is a girl's best friend, because 55 Cancri E is actually just a massive diamond out in space orbiting a distant star. When 55 Cancri E was formed, it was comprised mostly of carbon, and thanks to the intense pressure and heat from its parent star, 55 Cancri E compressed into a massive, unpolished diamond. This diamond planet is so huge that it has been valued at an incomprehensible $26.9 nonillion, which is only about 384 quintillion times the Earth's GDP. But before you set out for this diamond planet with a drill, 55 Cancri E is located over 40 light-years away from Earth. And if you were still somehow able to bring the diamonds back with you, the sheer amount of diamonds you would collect from the planet would crash Earth's diamond market instantly, making your diamonds completely worthless. Gliese 436 is a recently discovered ice planet that is about the size of Neptune. While that alone may not be very surprising, what is surprising about Gliese 436b's is that it's so close to its parent star that its icy surface is constantly on fire all year round. So you may be wondering, how could this happen? How could ice, of all things, burn constantly? Well, astronomers have determined that the reason why the icy surface of Gliese 436 never melts, despite the hellish inferno on its surface, is because of gravity. The gravitational force of Gliese 436b is so strong the ice covering its surface is physically prevented from evaporating, leaving the planet perpetually enveloped in icy flames. WASP-12b is a planet that orbits dangerously close to its parent star. WASP-12b orbits so close that it is slowly being eaten alive. Every orbit drags more of the planet's mass into its hungry star, and because of the immensely strong shearing gravitational force originating from its star, WASP-12b has even been distorted into an unnatural egg shape. Gliese 581c is a planet that scientists have concluded could possibly support life. But Gliese 581c is no ordinary planet, and even though it could theoretically support life, it does not at all look like Earth. Gliese 581c orbits a tiny red dwarf star, and because it is tidally locked, one side of the planet is constantly subjected to harsh sunlight, while the other half remains forever shrouded in darkness. The only place where you or anything else could survive on Gliese 581c is in the narrow strip of twilight between the two sides, where the temperature can support life. The skies of Gliese 581c are a deep crimson, and every plant on the surface would have to use infrared light for photosynthesis, giving them a deep black color instead of green. Because of this planet's amazing potential for life, in 2008 a message was broadcasted directly at Gliese 581c in hopes of making contact with life there. The message should reach Gliese 581c in 2029. Nicknamed Waterworld, a planet cataloged as GJ1214b has been identified as an ocean planet that has absolutely no land, not unlike the water planet seen in the movie Interstellar. And anyone on the surface of GJ1214b would only see ocean in all directions. The global oceans on GJ1214b are also miles deep, stretching all the way down into the planet's core, making GJ1214b a unique water planet. WASP-17b is very unusual because it is the largest planet ever discovered. Coming at over 1.9 times the size of Jupiter, WASP-17b's size and low density has confounded astronomers. In fact, it is so large that WASP-17b's existence violates our current understanding of how planets form. Perhaps even more oddly, WASP-17b has a retrograde orbit, meaning this planet orbits in the opposite direction of its parent star. Most planets do not orbit this way, making WASP-17b a rare stellar mystery. Known as HD 188753, this planet is located in probably the most bizarre solar system in the known universe. Located 151 light-years away, this planet's solar system has 3 stars. That means anyone standing on HD 188753 would have triple shadows, witness almost daily solar eclipses, and see a sunset no matter which direction they faced on the planet. If you want to travel the universe with us to all these magnificent planets, be sure to like and subscribe if you haven't already. And if you want to hear my voice some more, come check out my channel in the description. Or if you didn't like the video, I'm sorry, Dave. I can't let you leave a dislike. That's what he says in the movie, right?